Hello, my beautiful computer science students. Welcome to another lesson in Unit 3, Class Creation. This lesson is going to be lesson 2 in our series, and this is going to be all about program design. So in lesson 1, we talked about the impacts of programming as a whole. Here we're going to narrow down into our Java unit and really talk about the design of a Java program. Now, most of this is going to be review from Unit 1, where we touched on just the basics of object creation. So we're going to kind of recap all of that, summarize it, and talk about what we're going to see moving forward and how we're going to build on these class concepts we already know and make them into something pretty fun. So go ahead and grab your notes, get settled in, and we're going to go through program design together. So anatomy of a class. So remember, in general, classes themselves have two primary features, right? They have attributes, which we call instance variables, and that they have behaviors, which we call methods, okay? So a class as a template for an object is going to have attributes and behaviors. And attributes are the data, okay? Also called fields, instance fields, all of those things, a bunch of different names for it, right? But we control our data with variables, okay? So we set up data to hold, we set up variables to hold that data. And then objects also have behavior, and we use methods to define that behavior. So we're going to take it back to our dog class, which was first introduced in Unit 1, but now we're kind of coming full circle. We're going to go through what we've already know about this dog class and how it's created, and then kind of look forward to what's coming up in this unit that we're also going to add to our dog class to make it truly complete, right? So we start off with public class dog. So this is going to be a template, a blueprint, if you will, to make a dog object. So the first thing that happens in your class is you're going to list your instance variables, right? So we came up with 3 for our dog. You can come up with however many you want for any object that you have. We have string name, int age, and Boolean good dog. True if they were a good dog and false if they were not a good dog. And we said how all of them need to have private access. I'm going to talk a little bit more about that in this section of notes actually. But I told you, just trust me, it's all going to be private for now. I'll expand on that more in a little bit here. But all of the instance variables are going to have private access, and they're all just declared at the top of your class. You don't actually give them any values at the top here. When you give them values, that's going to happen in the constructors. And there were 2 different types of constructors. The first one is the default constructor, which has the same name. It's public, and it has the same name as the class dog. The default constructor has nothing in the parameter setting. It just sets those same 3 variables to default values. So name is going to be none, age is 0, good dog is true. And I see I left off a semicolon there, but there should be a semicolon at the end of true. But that's your default constructor. The other type of constructor was our parameter constructor. So that's going to have public dog, and then again, string n, int a, boolean g. So those 3 are examples of 3 parameters that you can give the constructor to construct a dog. And those 3 parameters would represent data we already know about a dog once we wanted to construct them. And they would just get assigned to our instance variables that we have. So name, age, and good dog, we would just slide that data right into those positions with the variables. So those were the 2 types of constructors. We also have other types of parameter constructors. You could have all 3, which I just showed. You could have 2 parameters. You could have 1 parameter. You can mix and match different data types, right? So in this example here that just appeared on the string n, int a, would be only if I knew the name and the age of a dog, but maybe I didn't know if they were a good dog yet. So I'm just going to default that to true, and time will tell, right? So that would be an example of using a different type of parameter constructor. And then what's coming up, okay? We've talked about some methods, some different types of behaviors, but what's coming up in this in this unit, we're going to talk about accessors and mutators. In other words, how to access and mutate data once a dog object is already created. We're going to talk about our toString and our equals methods that we're going to want to write for every class that we create. And then we've talked about other methods, we've created other methods, but we're going to make some more interesting methods that are going to interact with our objects in this unit. Okay? So remember, classes are really useful for representing things that have multiple data attached to them, right? So if we needed a variable just to count like how many dogs, right? That's just one set of data, right? We don't actually have, if we don't need information on the dogs, we don't need to know anything about the dogs. If we just wanted to count the number of dogs, we have a single variable and we can take care of that in our program, right? We create a class to represent an object when there's multiple data attached to them. So dogs have names, ages, if they're a good dog or not, and many, many more pieces of data that we could add to each individual dog. Okay. Now, to accomplish this goal, to handle all of this data, we use classes. Okay. A dog class stores all of the relevant information for each dog object that we create. Okay. When we create a new class, there's a few things you want to keep in mind. Okay, so to remind you of these, the class name is always capitalized. The class should go in its own file in the same directory as the rest of our files for a given project. So when we work in the main class, whatever that's called, where we have our main method, that's its own Java file, that .java. When we make a class that is going to be used in the main method, we want to make that own class. It's going to have a .java file extension, but we want to make sure that it's located in the same directory or the same, essentially the same folder as that main method so that we can locate it. Okay, so we use CodeHS, whatever IDE. If you're watching this and you don't use CodeHS, you're going to make sure that you can locate your same directory. And CodeHS, what that's going to look like, if I have my main.java here, where my main method is, I need dog.java, and make sure that you name it with the .java file extension after it. Don't forget that, but it has to be located in that same file, or when you go to make a dog, it won't be able to locate it, and you'll get an error message. Okay, so instance variables. So remember, for dog, we have name, age, and good dog. Okay, it's always at the top of our class. We create these instance variables these are all attributes that our dog objects will have. Now, instance variables represent what we call a has-a relationship. Every dog has a name, has an age, has a good dog. Every dog created is going to share these instance variables. Okay, now, when I say share them, we know all dogs have them, but the data stored is going to be different for each dog. And that's the beauty of these classes, is that it lets us organize and make each dog so that they're the same, but they are going to have different data stored in each of them. Okay, so it's going to be organized in that way. Now, when we declare these variables at the top, we want to make sure that they are private. And they're private, meaning that other code and other classes can't change their values. And the only class that can change these values and these variables are going to be in the dog class themselves. So private just means that outside classes can't access or change it. Inside the dog class itself, you can freely access and change these instance variables, okay? And we'll see examples of that throughout this unit. In the dog class, that is okay to change them. Private means outside classes cannot grab or change that information. Okay. Constructors, a few things to remember about constructors. To create an object, you have to call a constructor, okay? You can't just declare it in your main method. You have to use the new operator and use a constructor. Okay. If you don't make any constructors, Java will automatically add a default one for us, where it gives the instance variables those default values, where like strings are an empty string, age is 0, or I say age is 0, but ints would be 0, etc., like that, right? But it's good coding practice to define your own. Now, on the AP exam, you don't necessarily need to make one because you have a limited amount of time to create the classes. So on the AP exam, on the free response questions, when you're asked to make a class, you want to just make the pieces that they ask you for. If they don't ask you for a default constructor, you don't have to code one. That's just going to take more time than you have. So just know that Java will automatically actually add a default one in the background. It won't insert it into your code, but it'll have one in the background running if you ever need it. In addition to the default constructor, you want the parameter constructors, where you create our object with some initial values. And you don't need a parameter constructor, but again, it's good practice to have at least one. And you can have as many parameter constructors as you think you want or need in your program. They are always public and they have no return type. They're always public because you do want other classes to call on them to construct a dog object. So they need to be public in that way, okay? Now, the way we can organize all of this information is with what we call a UML diagram. So UML stands for Unified Modeling Language, and it's a type of diagram that allows you to kind of visually represent a class and the relationships. So I'm going to show you an example of a UML diagram just for like a dog class, right? UML diagrams are also very helpful when you start getting into like inheritance and abstract classes and all of that good stuff, because it just is a visual way to show all of those relationships. For us right now, we're just keeping it simple into one UML diagram. It helps programmers kind of plan and understand how objects interact, okay? Now, in these UML diagrams, a subtraction sign before a variable or a method represents private designation, and the plus sign represents public designation. Okay, so here is an example. It consists of 3 sections. Okay, so the first section is the class name, identifies the class name. So our example is dog. The second section contains the attributes. So it lists all the instance variables along with what their data type is. So you can see I have a subtraction sign for all 3 of mine because they are private. I have name, age, and good dog, and then the colons after that define what data type it is. Okay. And then the third one is the behaviors. So this shows the methods that are going to manipulate the data. And for me, I coded 2 of these in Unit 1. They're both public, speak and get age. And then after the 2 semicolons there, it's going to be what their return type is. So the actual UML diagram itself is going to be what I'm outlining in red here. This is the diagram that you are going to see or make that organizes all the points. Now, some UML diagrams will include the constructors. The examples I've seen on the AP exam, they do not include the constructors at this time. So I am following what the CSA exam is going to be doing, and in the examples they've given us so far, they don't include the constructors as part of the UML diagram. But just know that when you look it up online, some people do include constructors. Sometimes it really just depends on you as the programmer and how you want to communicate your program. Okay, but you got to be able to read one. So look at that and know what it means. Okay. All right. So let's talk about that data encapsulation. This idea of public and private and what exactly it means for you. Now, encapsulation is what we call one of the pillars, one of the 4 pillars of OOP, or of object-oriented programming, because it protects data from being changed. Okay, there's 4 pillars of OOP. Encapsulation is one of them. Abstraction, polymorphism, and inheritance. Okay, and we used to kind of talk about all of those in AP CSA, but we've kind of gotten rid of a few of them. So encapsulation is kind of the big one now that we cover in CSA. But what you have to know is it just protects data from being changed. When instance variables are declared as private, it means only the class that created it can call and modify that variable. When methods are declared as private, it means only the class that created it can call on it, and outside classes can't call on it. Now, being public or private, it's just a way, or really just making stuff private in general, it's just a way to protect data, and it's just, not only is it good programming practice, but it also lets you make sure that you are keeping organized programs. Okay, so it's just good practice, because right now we're at the top point in the course where it's like, well, who do I have to protect the data from, right? But what you're building now is foundational knowledge for larger things in the future. So just know that in OOP, encapsulation, protecting data, it is so important. So we want to instill those values in you now. Okay. So this is an example of some code segments that go along with that. So consider the following segment of code which appears in a class other than dog. So that means when you see those words, that means that you have your dog class, but this code is going to appear in another class, right? So if I have dog, doggy equals new dog, and then I have Scrappy 2 false. So I can constructed this dog, name of Scrappy, age of 2, false, Scrappy is not a good dog. Okay. Now if I try to say doggy.gooddog equals true. Okay, so maybe Scrappy, he started off as a bad dog, but now he's a good dog, and I want to change that, and I want to change the data to reflect that. If I have doggy.gooddog equals true, so doggy is my reference, okay, because doggy references my dog object. Doggy is my reference, good dog is the instance variable, and I want to set that equal to true. This code does follow proper syntax. If the good dog instance variable was public, this would actually correctly change doggy's good dog to true. But because good dog is a private instance variable, you're going to get this error message when you try to compile. Good dog has private access in dog. So you won't be able to do that. Okay? Now, if you wanted to change, because changing data is a valid thing you might want to do in a program. You created the data, you store the data, maybe you do want to change it, totally valid. We're going to talk about the correct way to do this, okay? Right now, this is an incorrect way to do this. This does not follow good encapsulation practices. Even though it's valid syntax, because good dog is private, it won't compile. But making good dog public and having this be a correct syntax, it still does not follow good OOP protocol, okay? So don't do it. Don't do it. Here's another example. Let's just say, again, we make our dog Scrappy, and let's just say we want to print his name, okay? We don't even want to change anything. We just want to access it and print off what it is. Again, this code does follow proper syntax. Even though you're not trying to change anything about doggy, because the variable is private, you still cannot call on it directly. So valid syntax, doggy.name, okay, this would return, this would actually just get doggy's name and print it off if name was public, but name is not. Name has private access in dogs, so that means an outside class cannot call on it and access it, okay? So this appears, and this is specifically because this appears in a class other than dog. If we were to try to do doggy.gooddog equals true inside of the dog class for some reason, it would work. And we're going to see examples of that. In fact, we actually don't use reference, we don't use the reference names like doggy.gooddog. We actually use a keyword called this.gooddog. And I'll explain more about that in the next couple lessons, okay? So that's coming up. But right now, know that they have private access. You can't access them or modify them directly. You are going to have to use some methods, okay? Java prevents any data stored in those private variables from being modified or accessed, okay? So public means that it can be used outside of class. Private means it can only be used inside of this class. These are called modifiers. Public and private are called visibility modifiers. There is a third one called protected that you don't need to know for the AP exam. Protected more pertains to inheritance. When you start learning about inheritance, that's when you would introduce the protected modifier, because it allows certain subclasses to access data while protecting other aspects of the data. So protected is kind of like a mix between public and private, but it doesn't really come into play until you get into inheritance, which we're not going to get into in this course anymore. So you don't have to worry about it. For the AP exam right now, you do have to know the difference between public and private. Okay. If you do want to access data either by modifying it or just by seeing it after your object is created, you want to make use of accessors and mutators. Now, these are two types of methods that we're going to talk about in a couple lessons, how to write them and how to use them. So again, just to kind of wrap it up here, in general, when writing classes, you want to observe data encapsulation. Okay. And remember, data encapsulation means protecting the data by making it private. And this means that by making that data private, it's protected from other classes trying to see it and change it. Okay. And again, that doesn't really make much sense for a lot of the programs we are writing right now, but we are building a foundational knowledge to help make these larger programs when you continue your programming knowledge. So right now, use it. You want to practice this good data encapsulation idea, and then it becomes more powerful with the larger programs you make. Okay. And that brings us to the end of our lesson today on program design. So it was a good recap of everything we've gone through with classes, a good conversation about data encapsulation, and then where we're going to take these classes in the future. So if you have liked this video, please hit the like button and subscribe to my YouTube channel for more great AP CSA content. And until then, I will see you guys in the next video. Thank you so much.